Hey guys, welcome to the XP Solutions live webinar. My name's Sophia and I'm the Water Resources Engineer here at XP. Today's webinar is going to be focused on the integration of 12D and XP. Between the two products, we can really manage stormwater drainage from early stages of conceptualization all the way through to construction, operation and maintenance. We're going to show you how survey, civil and the stormwater teams can work together to optimise solutions in the scheme of drainage. I'll just quickly go through what XP Solutions is all about. So these are our main products. Here at XP Solutions we deal with everything water, from hydrology through to detailed design of quantity and quality. We also have products for water supply and soil modelling, and we actually have our own civil package as well, XP Site 3D. So as always, we've got a no questions go unanswered policy here. So if you've got some questions during the webinar, you can type it in the box in your webinar panel, or alternatively you can send us an email on the screen address below. So we have the pleasure of Rob Graham from 12D Solutions joining us today from his Sydney office. Rob has been working in the hydraulic and hydrologic modelling field for over 35 years. He's the lead in development and training of 1D and 2D drainage modules for the 12D model civil engineering design software since 1998. Hey Rob, thanks for joining us.
Thank you, Sophia.
So Rob, for our listeners that might not be so familiar with 12D, do you want to tell us a bit about the product?
Definitely. Thank you. Yeah, 12D Model is a civil engineering and design software package. So we're involved in civil engineering right from the very start of a project with the survey and LiDAR data. The data might also come from sources like GIS or CAD or the BIM these days. And today we bring it all together to form a data train model. Once we do that, we're into our design phase, and so we'll do roads, subdivisions, highways, utilities, services. All that is part of the 12D design. Once we get it all designed up, it's ready to go out back into the field for construction survey. So we'll take the final design, the surveyors will take it out on their small laptops with their survey equipment, set it out. They'll use it to run their automated grading machines, and finally as-built surveys in ADAC. So we cover the civil engineering design from the start to the end. So that's pretty well what we're up to.
Awesome. This webinar up on our XP Solutions website, so you can look at it later on. So just a quick overview of what we're looking at today. We're really looking at the objectives of urban drainage. Not just drainage, but today, because we're doing this integration with 12D, we're really going to focus on that. We're going to have a quick look at the guidelines and requirements, and then Rob and I are going to do a practical application of how you would actually integrate these two softwares. So stormwater is not new. It's always been a problem. We're just looking at better ways to try and manage it. So the reason we need to have a look at how we're going to manage this is we want to accommodate and promote urban development without negatively impacting the built environment. We want to assess the hydrology and the hydraulics, and also look at the management of water quality and quantity as a whole. And as you know, stormwater engineers, civil engineers, drainage engineers or environmental scientists, we need to look at all these things. We need to think about the water surface levels, the flow rates, flow hazards, the impact on safety, and accessibility for maintenance vehicles. We want it to be easily constructed and cost efficient. And to manage our stormwater, we have all these different types of elements that we can use. We've got pits and pipes, overland flow paths, detention, rivers and waterways, we've got major structures, and we've also got water quality devices. And we need to integrate all of these together to get a great solution. So some of the guidelines that we look at to do this, so I guess these are the most common ones we come across with our users. Australian Rainfall and Runoff 2016, that came out, final chapters came out last year. And if you haven't managed to catch our last couple of webinars, we're actually in the development of implementing the hydrology, which there's a fair few changes. So something to look for in the upcoming months. Queensland Urban Drainage Manual, and then there's also some guidance there for Malaysia, New Zealand. So at the end of the day, urban drainage and stormwater, it does seem like the drainage engineer's problem, but the solution is really created by the whole civil team. So, we're not just putting pits and pipes in the ground, we're using our roads and our parks as overland flow paths and storage to get a real solution that works together through all the different phases of a project. So we're going to have a look at the practical application of that, and I'll probably hand this over back to you, Rob, who will start off with an actual 12D project that we're going to have a look at, and we'll move that into XP and then back out again. So Rob, I'll hand that over to you.
Okay, thank you, Sophia. I'll just wait until the view switches over so you can see the 12D model. There we go. So what we're looking at here now, it just takes a moment for it to refresh for everyone, is the 12D model working environment. It's a shared design environment. So just looking at these three plan views you have in front of you, data has come in from a surveyor. Now that surveyor has worked on a separate version of 12D, and they've got the survey data all ready to go, and they've created a data train model. On a separate designer might be the road designer, who's going to go and create all the roads, do the road grading, do all those wonderful things that a road designer does. And when they're finished, they'll share that across to us, the drainage designers. Now, those come together to what you would probably see now in the right-hand screen, where you can see the data train model combined together with the road design, and then you can see the 12D drainage string. And the drainage string consists of what you might expect, nodes and links, or inlets and pipes. And now with BIM being such a huge issue in the civil engineering design process, you can see things like we've got the objects there for the inlets, where you can see as much the detail as the grates. So yes, that's the process that we're going to go through. Now to talk just a little bit about the stormwater design inside 12D. I'm just going to switch over to another view which has my stormwater on it, and bring over one that's also got my long sections on it. So when it comes time for the inlets and the pipe systems, or open channel, whatever you're putting in for, because Sophia mentioned the many different components of a waterway system. The original structures, probably the easiest way to create them is to create them inside 12D, because you've got your roadway center lines, you've got your curb inlets, you know exactly where these structures are going to go. Now, the reason we want to be careful about that inside 12D is that when we're finished, this model will be used for construction. So keep that in mind. On your phase one, it's not so important that everything's in an exact position, but when you get down to your final design, you want to make sure that the locations are correct. Now, you don't have to start inside 12D. Sometimes your design will have been started somewhere else. It could have been in a GIS system. It could be a CAD drawing. It could be a swim input file. If you dragged and dropped a swim input file into 12D, it would create those pipes and inlets that you see there. So you may not start in 12D, you may start somewhere else, but then once the data gets brought into 12D, we're ready to go on the design. The levels. There's one thing I found very tedious as a stormwater engineer, and that was typing in levels. I love hydraulics, I love hydrology, but typing in levels gets to be a bit tedious. So the way our design environment is set up is I'm going to bring up our drainage network editor, which is really the heart of 12D's drainage work, and go across to our pit tab, which is where we would have all our elevations for our structures. Now the choice is up to you. You can have all the elevations. For example, the ones that we have here, you've got the cover level, you've got the grate level for the structure, you've got the sump levels. All those levels can be automatically calculated, or they can be entered in manually if you wish. The next part of the pipe system is, of course, to make sure that we've got the adequate cover for all your pipes, and to make sure they've got good grading to go with them. So 12D is quite proud of the grading algorithm that it has to make sure that we've got the proper slopes on the pipes and the proper cover on the pipes, measured, of course, using the pipe thicknesses up to the surface. So those essence of getting the physical characteristics of the drainage network correct is what 12D is particularly good at. When it comes time to set up the hydrology, before we send this across to SWM to do the Lawrenson work, we're going to run a rational method design on it. And that's going to size the pipes and get them to the approximate size that we would need, or if you're a lover of the rational method, it would be the exact size that you want. And to do that, we would draw in our catchment areas, all those sort of basic input data. Whenever you're working inside any drainage work, we always work with our default values. The concept of the defaults is that you can set the default method for the levels or the hydrology or hydraulics to be calculated, and then you're always welcome to move across to the explicit tab where you're welcome to override any of the settings. So our system now, it has been graded. We've got the minimum grading. We've done the pipe cover. We also make sure that we don't clash with the other services. 12D is a full service package for modeling all your different conduits, everything from lamp posts, foundations, to your electricity, your Telstra, your telecommunications, all those sorts of things. So we check for service clashes at this point to make sure that at least we have a plausible network before we send it across. The other thing that we do is that when it runs the rational method, it'll calculate the KU values. Those KU values are calculated from the rational method flows, and those will be transferred across to SWM as well. So let's get on now and get to start talking about how we interface. The button that we're looking for is our import-export button. And you have a choice of the package, and we're exporting to XPSWM. Now this would apply equally, of course, to XPSTORM. And it's going to create an XPX file. These XPX files are what XP Solutions is going to read in. And we have our tick box that sits here on the export button right now. And so our job to do is to come down and hit the run button. Once we hit that run button, it's going to export all that data and create an XPX file. Now an XPX file is not fun reading at all. As a matter of fact, make sure you're sitting down the first time you open up one. There's one command for every single property, so they're quite long, but if you are keen and interested, you're more than welcome to look at that XPX file before it gets imported into XPSWM or STORM. What controls how that's created is what's called a drainage mapping file, and we'll talk a little bit more about that drainage mapping file later. So that XPX file is ready for Sophia to read into XP. The other bits of information she's probably going to be interested in is a data train model. So the data train models can also be taken across into XP, of course. And what we're looking for here are our TIN models. And the model that you're going to be looking for is the set that end in tin dot a number, and they go from 0 to 9 and then 1 without a number. So that whole set of 11 files, 0 to 9 plus the extra one, is the set that XPSWM will be able to read in. So after covering all that, Sophia, I think we're going to go back to you now and see how you bring that data back into XPSWM or STORM.
Okay, thanks Rob. I'll just wait to grab my screen and hopefully I can get the right one this time. All right, so I'm just going to open up XPSWM or STORM, They're both work exactly the same for this process. And I'm going to create from a template. Just give it a name. And then I need to go and pick which template. So this is a template I've set up that's going to work with 12D's model that Rob set up. So I just want to open that one. I'll just show you a quick view of what's actually in there. So we've got the pit rating curves, which match what's in 12D. We've got some rainfall data, and we've also got some infiltration. And they're the things we're going to be using, well, not so much the rating curves, but the rainfall and the infiltration is what we'll be using to run the Lorenzon's method for the hydrology. Now what I'm going to do is import the XPX file that Rob has exported out of his model. So File, Import, Export, and I just need to go and grab that file. And hit import. And what I've actually just done is imported it all into the hydrology layer. So we want to take all the links off that one. So I'm just going to highlight all those links and take them off. So if we go into one of these nodes, we can see the areas actually transferred across from 12D, and 12D's mapping files automatically calculated the impervious areas and split them, which we use for the Lorenzon's method. So in the Lorenzon's method, because of the calculations and the parameters that it uses, we like to split the impervious to 100% and 0%. And if we go into one of these nodes, it's already selected the Lorenzon's method based on our mapping file, and the defaults for the calculations are in there already. We've also got some rainfall and some infiltration straight from 12D. And if I open up XP tables, I can have a look here at the catchments that are actually connected in the model. So we can see there some of them are ticked off. So they're the ones in 12D that have come across that don't actually have a catchment connected. So what I'm going to do there is just select all the ones select all those and make sure that there's no outlets or junctions that actually have connections, catchments connected to them. And while I'm there, I'm just going to save that view as the inlets. And the other thing I want to do now is just turn off the ones that don't have a catchment. So select those outlets and those junctions and take them off the runoff node. All right, so we're pretty much ready to run now. I might just import those other data pieces that Rob was talking about. So we've got a background image, and this is the same file that is used in 12D. We can just bring that one straight in. And I'm also going to bring in the terrain models. So these are these tin files that Rob had shown previously, and does a quick conversion and brings it in. So that's the design surface, and now I'm just going to bring in the survey. And I'm just going to change the display of those so that we can actually see what's going on. So you can see the design roads there, and the survey underneath. So I'll just turn the aerial off, and we'll now look at running the hydrology. So I've just set that for 2 hours at a 60-second time step to run it quickly. And I've actually set up some global storms. So I was just talking before about the changes in AR&R 2016. And one of those changes is we're moving away from the single storms and into ensemble events. So you can see here I've got the 10-year 60-minute storm ensemble, so 1 to 10 for the Gladstone region, and I've also got the 87 temporal pattern, so single storm there just for comparison. And I just need to make sure that I'm just running the runoff mode rather than both. Because I'm running 11 storms, I'm actually going to use XP's latest feature, which is actually the Solve Manager. So I'll click Solve. And what the Solve Manager does is it actually parallelizes the runs based on how many physical cores your machine has. So unfortunately my laptop's only got 2, so it's running 2 at a time. But as you can imagine, if you've got 4, you'll run it 4 times faster. So that's done there. And if we click on a node, we can then graph the results. And for anyone who's not used to running these kind of patterns, you may be used to using the rational method, they look a bit funny. It's a function of not only the Lorenzon's method or traditional hydrology methods, but also the catchment's quite impervious. So the water is actually matching the temporal patterns. So I'm quite happy with that. If you were doing your real project based on AR&R 2016, you would then run some statistics on your hydrographs and work out the hydrograph that was appropriate for the risk of your project, typically the median, and you would just run that one. So I'm going to follow that process, and I'm just going to turn a single storm on to run the hydraulics. You could always run all those storms through the hydraulics, of course, but for today's presentation, I don't want you guys sitting here for too long waiting for the computer to solve. So I just need to turn the hydraulics mode on now, and I need to grab all my links back and turn them on. And I'm just going to make sure all my nodes are turned on. Okay. Now when I double click on this node, we're going to have a look at the hydraulic parameters that have come across from 12D. So I've got the invert and the spill crest or the grate level. That one doesn't have an inlet capacity, so not that one. And that's all that one does. So if we go down to one of these ones, you can see there the information of the pits actually come across from 12D. One other thing that's quite good coming from 12D, if we go to a link, we can see there that the pressure change coefficients come from 12D. And that's populated based on the rational calculations that Rob has run before he's exported that. So we're obviously going to run ours in hydraulic mode and update them where we need them. So what I'm going to do is I'm just going to turn this into a 2D model straight away, and I'm going to draw a rough grid around the extents of the project. The smaller you do this, the quicker your model will run. And just come up here and close it off there. And the other thing I need to do is just add a head boundary so the flow can actually escape the model at the downstream end. And if I make that level less than the topography, it's going to create a free outfall. So you can see there we've set it at 20, RL20. So I've got one last thing to do, which Rob told me late last night that he could have automated this, but that's okay. So a small improvement we can make in our 12D XP mapping files. But at the moment you can see that all the pits have the link spill crest to the 2D, which is great for our gully pits, not so great for our head walls. So what I'm going to do is I'm just going to go back to XP tables again. And in our junction data, I'm going to search for any pit that has an outfall. So we can see I've got those 5 there. And what I'm going to do is I'm going to change those to link invert to 2D. And I want to turn the outfall flag off, because what that's actually doing in the 1D hydraulics is letting the water out of the system. So if I've got that on, the water actually won't come out onto the 2D. It's like it's got a hole in the terrain, essentially. So I'm just going to turn on the hydraulics mode. Check the hydraulics runtime, which is at 2 hours. I'm going to try and run it at 60 seconds. And the last step is to set up the 2D job control. So first things first, turn it on. And we're going to set a time step at half the grid size. So at the moment I think I've got a 1 metre grid, so I'm going to go 0.5 seconds. I'm going to set the default land use as roads, which is the majority of our site. And that is all I need to do on that page. These will all be set up in the template. Turn on the folder options. And the last one I wanted to talk about was the advanced settings. So this one here is going to create a TMO file for the output, which is actually going to be read straight into 12D. So there's no importing and exporting, it's going to be read straight into 12D. And that's created as the model runs. And and we're going to use the terrains that are turned on in the model. I'm going to hit save. Just double check that I've only got one storm on, and I'm going to hit solve. So that'll take a little while to process. This is usually the time that I would actually go and make myself a cup of tea, but I think that'd be a bit rude while I'm running a webinar. So what I'll do is I'll hand you back over to Rob to have a quick chat about some of the other things in 12D.
Okay, thank you, Sophia.
And,
yes, if you sit there and watch a 2D model solve, it's a little bit like watching snow melt. It takes a bit of time. It's not that exciting.
So I'll just hand the screen back over to you, Rob.
There you go. Okay, we'll give that a moment to refresh. If you recall, before Sophia had started that work, the very last thing we had done was exported and created that XPX file. When Sophia was talking about her project, she was referring to the inlet capacities, and I thought I just might take a moment to let you know how those inlet capacity curves are selected inside 12D. So first of all, what we do is that inside 12D, we've got our pit types, and the pit type would reflect the type of grate that you had on the surface, whether it was a lintel or just a grate by itself, and that would determine the inlet capacity to start with. The second decision you need to make is whether it's going to be an on-grade or a sag pit. And we don't need to talk a lot about that, but we essentially have those choices, or a manhole which won't accept any water at all. So once you've selected the road pit, the type, and the inlet configuration, what 12D does is, because it's a fully integrated package, it will go measure the road grade and the road crossfall from the DTM data. So if I go back into here, you'll see that it's gone and measured the road grade and the road crossfall at the pit location here, just a little bit upstream and just a little bit out towards the road center line. Once we've picked up those two pieces of data from the data train model, we can go to our database and select the appropriate curve. So if I went to our drainage sewer menu and just popped down to our database, which is the drainage.4D, now our drainage.4D is just like the global database that SWM would have, or very similar. And if I come down and just take a look at that inlet that we were just looking at, which was a road pit, and in an on-grade configuration, what happens is we would go look at the road grade and road crossfall. So any road grade and road crossfall greater than 0, because this is our flattest curve, would get this name assigned to it. So SG for a grade, 0.5% grade, 2.5% road crossfall. And you'll see that the next one takes over at 0.75. So we switch between the curves depending upon the road grade and the road crossfall. So this is the part that you do want to make sure is consistent between the two packages. Those names that you see there, this name up here, that's the name that gets sent across to XP. And once XP has that, it relates it back to its global database, and it uses the inlet capacity curves that are inside there. So that's just a little bit of a background into how 12D selects the appropriate inlet capacity curve for SWM to use for its calculations. So now we've finished that, Sophia might transfer back to you, and we'll just take a double look and see how that 2D model is running.
Yeah, great. That was a perfect amount of time, I think.
Glad to hear it.
Okay, so we're back on my screen, and I've just turned on the maximum water depths there, and you can see in the model, I'll just turn that grid off actually. You can see the water coming down these curbs, and where we've got possibly some issues. In this little dialog box down the bottom, down here, where we've got the X, Y and Z, when we hover over that water depth, we can actually see the values there. So at the moment, hovering over that depth in the road, and we've got nearly 300 mils. So this is a case where you may want to change and update your model in XP to take those flows and reduce the flood risk and possibly flood hazard. We can do all sorts of things with those results. We can play it as an animation. So we can see the water build up over time. And we can also look at the long sections. And we can see the water there building up in the model, and this is where it's discharging onto the 2D. So any changes we make to if we want to fix this problem, we're going to increase the pipe sizes, or maybe it's an inlet problem, so we're going to increase the pit capacities. We want that to go back to 12D. So we want the updates to the drainage model. We want the HGLs from our dynamic hydraulic run, and we want the water surface elevations and the depths and the hazards and velocities to all go back to 12D. So to do that, I'm going to go File, Import, Export, and like we did when we brought it in, we imported it, we're just going to export an XPX file. And 12D really only needs the nodes and links here. Now I'm going to send that one to Rob. And the other one we want to look at is the TMO files. So we go into the project folder, the results and the outputs. We can see those TMO files that have been created. So you just want to, there should be 5. You just want to package those up and send them back to 12D as well. So Rob, I'll hand it back to you, and you can show the guys how to put it back into 12D.
Perfect, thank you for that. So we'll just give a moment for our screens to switch back over. Somehow I still find it somewhat amazing that we can switch screens between Brisbane and Sydney so quickly. So back to 12D. If you had remembered just before I took that diversion on to inlet capacities, we were sitting on that import-export panel. Well, what I'm going to do now is to go down and pick the XPX file. And for those of you that are very attuned, you will see that there's a 003 added there. Yes, I did receive this last night. We haven't sent that over the internet, but it's the file that we're looking for. So we need to come down and turn this button down here to import. Now on the import tab, it's of course going to read in the data using that drainage mapping file, but we're also going to update our plan labels and our long section drawings at the same time. And that uses plot parameter files, which are 12D's way of customizing what those drawings look like. So when I go select the run button on that, it's going to go and read that XPX file and loading the maximums, so maximum water levels, maximum flows, maximum velocities. So now if you might have noticed there, all of a sudden my long section updated. That's got the maximum HGL levels from that swim run. So we'll move that across there. The other thing, of course, if there had been any changes in pipe sizes or levels, those would have also come across back into 12D. And at the same time, whenever we do any imports back in, we once again rerun the crossing service class checks and the grading checks just to make sure that everything is still within the original tolerances. You might have noticed that the labels are a little less complicated as before because we haven't brought as much data back in from XP, But we've got our catchment flows, we've got our pipe flows, and they're labeled up with the diameters that have come back. So that's our updated plan drawing. If I was to move across now to our long section drawings, those long section drawings were created from the plot parameter file here. And if we zoomed in a little bit closer, you can see that once again, that has the maximum hydraulic grade line results that have come back from SWM. And if we come down a little bit lower, we can have all of our hydraulic grade line data put in a tabular format down at the bottom, along with a lot of the other physical properties. Now for this case, I've gone and asked for these long section drawings to be shown inside 12D, but we could just as easily put on a title sheet to that, export them to a PDF with the title block, etc., so that it would be ready to go to your client. So that was bringing the results back in the updated data. Now from that updated data, of course, if you were working with BIM modeling, we would be able to export the BIM images. If it was ADAC modeling that you were concerned with, the ADAC attributes could all be added to it as well. So the next thing you mentioned, I might have noticed that Sophia exported those TMO files for us. We're going to go read those TMO files, and for that I'll go to the Drainage 2D. And the first thing I'll do is I'll come down here and select the Read button. Now there was 5 of those files, so I'm going to tick on the Many Files button, and I'm going to create what's called a grid tin inside 12D, and I'm going to give that a name. We'll call that XP, and we'll go and read that in. So that reads that in very quickly. What it does is it links the 12D grid tin up to those files, and the next thing we want to do is to be able to take a look at them. So we can finish that tab. Let's go back to our 2D, and we're going to change the tin settings for them. So I'm going to come here and I'm going to select the XP tin that we just for the results. And my plan is to show it to you on the 3D view. So I'm going to make sure that my tin depth is set, my tin inquire results is the water levels, so that it's shown at the correct water level. And then if I want to color the surface, I have a choice on which parameter I'd like to color my water surface by. And in this case, I'm going to color it by depth. And I can hit the set button on that, or move back to the last one, previous. Then if I move across to my 3D view, we'll get these ones out of the way for ourselves. Actually, I can get rid of this as well, just clean up my view just a tad. There we go. So we might just bring that a little bit bigger. And let's get rid of this view here. All right, we could go and add on that tin XP. And if we zoom out, okay, currently what we have is we've got the depth ready for coloring, but we haven't put that coloring on it just yet. So those are the results that you would have seen inside SWM. If I come back here now and go to the toolbar one more time, I can create a legend and a coloring for this tin. And so the first thing I'll do is just pop into our library. We've got some color coding bands that we ship 12D with, so that picks one of those, or you could use a range file to create your own. But what this does is it does 2 things. First of all, when I hit the create button on that, it creates a legend for me, but it also goes and applies the color coding. So if I just move this back here across and go to my legend view, and if I do a fit on that one, okay, that's got the legend that was just created. So now I've got the color coding legend to put on a drawing to go together with the water levels that you see there. So essentially that's what we're looking at. Whether I show depth, whether I show velocity vectors, arrows, whatever, that would all be controlled by this tin settings. So probably the very last thing we want to show is a flyover. Frequently people, when they do the flooding, they want to present the results. A flyover across the project is a good way to show the entire area up close at times. So to do that, we use our visualization. So if I go down to our visualization and go down to my timelines, I'm going to select Edit and down here to the one I'm interested in. Now we won't spend any time going over the details of a timeline at the moment. This one is set up for our 2 flow results, and there's a line been drawn inside 12D that it's like the camera track that the camera goes down. I'm sure you've all seen that in Hollywood making of movies where the cameras travel down a track. Well, they do that inside 12D as well, and the track that it's coming down is approaching there from the southeast, And while we're moving down the track, we're taking a look at the flood results being displayed as the flood progresses. On the timer, if you see this is sitting at 24 and 25, those are the 25, 20, 30 minutes of modeling time. So I know I'm at the 30-minute point in my flood, and then that's going to start receding off, and we'll be down to the end. Now, if you wanted to ship this off to your client, you could just ask 12D to record a movie, and that would create a movie to send off. So that's another way to look at your results inside 12D. The final step for 12D users is often to, of course, take this out into the field and get it built. So it'll go to a survey using our 12D setout. If there's quantity calculations to be done, we'll do all the quantity calculations. And of course, if there's BIM objects that are needed to be created and sent across, we would do that as well. So Sophia, I think that pretty well wraps up the end of what we would do with the results once they got back into 12D. So I might just turn that back over to you.
Okay, great. And I'll just share my screen again. So those two files that Rob and I have created and used in today's demonstration are going to be available online so that you guys can use them too. So Rob, I don't know if you want to just quickly describe where the users actually need to put that swim.dmf?
Good question. 12D has what's called a working folder. That DMF file would sit inside your working folder. And that DMF is particularly set up for the Lawrenson. If you were using some other hydrology method, could be altered, and I think it will plan for some future ones so that they could be used for EPA hydrology, SCS hydrology, whichever the case. And yes, those definitely sit inside the working folder.
Yes, that's a good point, Rob. As we do build those ones, we'll make them available as well, so users can access those for different types of hydrology and inlet pits and whatever else is needed. The other one is the 12D template, so that's how I've read in all the pits and rainfall and data that Rob sent me. And that one's just when you create a new file in XP, you just use a template rather than a blank file. So over the course of a project, you might be importing and exporting to and from 12D and XP a few times to make sure you get the optimal solution. So XP Solutions are going to be at some conferences coming up. Rob, you're going to be in Auckland as well, so I'll see you shortly.
Definitely, we'll be there.
Yeah, if you're going to be there, come and visit us. Come say hello. Let us know how your integration's going. And both 12D and XP run training sessions. Rob's told me that 12D runs them almost daily. So if you need information about what's coming up, just log on to either xpsolutions.com or 12D, depending on what you're after.
I might also add that 12D has a YouTube channel as well. So if you're looking for additional information, please feel free to look for us on YouTube.
Yeah, and it's actually the same with XP. If you're after any more information, we've got a whole heap of past webinars that are available on our website too. So that's pretty much it from us. All right, have a good day, guys. Talk to you later.
All right. Yeah, goodbye to all. Bye-bye.